This Navy diver wears a standard deep-sea diving outfit, a protection against the water in which he works, and a container for the life-supporting supply of air which he receives from the surface. Safety and efficiency require that the diver be thoroughly familiar with the construction, assembly, and use of his diving equipment. This film will show how the many parts of the standard deep-sea diving outfit are assembled, a process called dressing the diver. The standard deep-sea diving outfit is composed of the dress, helmet, and the breastplate, which together form a watertight enclosure surrounding the diver. The weighted belt and shoes used for overcoming the positive buoyance of the inflated dress, and the system of valves by which the diver regulates his air supply. Assembling these parts correctly is vital to the diver's safety, and thus, prior to dressing the diver, each must be inspected and tested. First, visually inspect the diving dress. Examine the fabric for tears, worn spots, or loose patches. Check the rubber collar for torn spots or excessive wear, especially at the stud bolt holes. Make sure that the leg flap lacings are in good condition and not worn to the breaking point. If any defects are found, place the dress aside for repair and select another dress of satisfactory condition. In examining the breastplate and helmet, first check the number stamped on each item, including the breastplate straps. The number must be the same. These parts are not interchangeable with like parts of another outfit. The number identifies the parts that go together to form a tailor-made unit of matching parts. With your fingers, check the 12 studs on the breastplate, making sure that none of them has become loose. Try the fit of the breastplate straps on the breastplate. They should go into place easily and conform to the curvature of the breastplate. Notice that to avoid mix-ups, the front straps are clearly labeled. Turn the wing nuts down on the studs to make sure that no threads have been damaged since the last dive. The copper and brass of which the outfit is made are relatively soft metals. Being soft, the threads are susceptible to damage from careless handling. Notice that 4 of the wing nuts have heavy flanges. These go on the studs where the ends of the breastplate straps join each other. Look for worn areas in the breastplate lanyards. If there's any doubt, replace them. Remember, these lanyards secure the all-important air hose and lifeline. The leather gasket recessed into the top of the breastplate makes a seal between breastplate and helmet. Make a visual inspection for tears in the leather and for cleanliness. Dirt or debris could prevent proper seating of the helmet, thus causing leakage. Apply a light coating of neat's foot oil to the gasket. This will keep the leather soft and pliable so that it makes a good seal. Now, double-check the helmet gasket by fitting the helmet to the breastplate. It should turn into place easily, but with some resistance. The helmet faceplate should face directly forward. And the safety latch on the breastplate should line up properly with the dumbbell on the helmet. Check these for security and proper operation. Take a close look at the helmet ports, especially for cracks or dirt. Clean them if necessary. Underwater visibility is seldom good, and dirty ports would further reduce the diver's vision. The faceplate is the only viewing port that opens. Check the condition of the rubber gasket and the operation of the hinge and swiveled wing nut which clamps the faceplate against the gasket. Make sure the cotter pin is in the hinge pin and secure. The two goosenecks at the back of the helmet are extremely important. This one admits the diver's air supply, and this one secures his combination lifeline and communications cable. Be sure they have not been knocked loose and that the threads are clean and undamaged. No part of the testing and inspection operation is more important than the attention given to the diver's air valve. Let's begin with the two valves built into the helmet. First, the exhaust valve. Check the operation of the hand wheel. It should turn freely. Operate the exhaust valve chin button. It should depress easily and return immediately when released. Pull the chin button upward, as the diver occasionally does with his lips, to make a temporary adjustment in his buoyancy. Again, it should work easily and return when released. Operate the chin button in this manner several times. Remember, the correct operation of his exhaust valve is important not only to the diver's efficiency, but also to his safety. Next, the spitcock at the left side of the helmet. This is a secondary exhaust valve and is used to make minor adjustments in the diver's buoyancy. It's a simple sleeve valve. The only test necessary here is to operate the lever, making sure that it has enough turning resistance to remain fixed at any setting. Now, let's look at the remaining two valves, each concerned with air supply. The air control valve regulates the amount of air admitted to the diving dress. Again, the regulating hand wheel should turn freely so that the diver has no difficulty in making adjustments in his air supply. However, it must not be loose. Enough resistance must be felt to prevent an accidental bump or blow from turning the hand wheel and thus altering the diver's buoyancy. Make sure the cotter pin is in place to prevent the hand wheel lock nut from backing off. Each of the male threads machined into the body of the air control valve must be clean and free of distortion. Check the link and eye pad used to secure the valve to the breastplate. Excessive wear or damage is seldom found, but be sure. The last of the valves is the safety air non-return valve, usually referred to as the non-return valve. Remove it from the gooseneck at the rear of the helmet and check the condition of the thread. You'll remember that the non-return valve is a spring-loaded one-way valve. Air can pass through it into the helmet, but it cannot travel in the opposite direction from the helmet back into the air hose. Check this by blowing a mouthful of cigarette smoke into the end of the valve that has the female thread. No air or smoke should pass through the valve. If it does, discard the valve and use another. There are two types of non-return valves in use. This newer type has a heavier spring inside, and the valve body is made in two pieces rather than one. The test is the same. Smoke blown into the end of the valve having the female threads should not pass through. Remember, this is one of the diver's most important safety devices. Never omit this test. Be positively sure the non-return valve is in perfect working order. Now reinstall the non-return valve on the helmet gooseneck. Next, carefully examine the belt, shoulder straps, and jock straps. Look for tears, nicks, worn areas, or elongated buckle holes. Treat these items occasionally with a coating of neatsfoot oil, well rubbed in. In addition, the tensile strength of these leather items should be periodically checked in this manner. A buckle is secured to the overhead, and the item to be tested run through the buckle. If the belt, shoulder straps, or jock strap can support the weight of a man weighing 160 pounds, its condition is satisfactory. To complete the testing and inspection process, check the diver's wrist straps and shoes for excessive wear and tear. Apply neatsfoot oil if necessary. Be sure the shoe lacings are not frayed where they pass through the eyelet. If there's any doubt in your mind about the condition of any item of the diver's equipment, check it out with the diving officer or diver in charge. It's better to ask a question than to take a chance on the safety of a human being. Before dressing the diver, connect the air hose and the lifeline to the helmet gooseneck. Do not, repeat, do not oil the leather gasket inside the lifeline gooseneck. Remember, the lifeline carries the communications cable. Oil on the contact points of the cable would interfere with the operation of the intercom system. Tighten the connections hand tight, then finish with a wrench. Be firm in tightening these connections, but don't use too much muscle. Stripped threads might get the diver into serious trouble. Check the air supply by opening the air control valve. You'll be able to hear the air rushing into the helmet. Dressing the diver is mainly the work of two men, the diving tenders. They are supervised by the diving officer or the diver in charge and assisted, where possible, by the diver himself. The diver is prepared for diving by donning one or two sets of diver's underwear, his choice determined by the temperature of the water and the amount of physical activity required by the job. To begin the dressing process, the diver slides feet first into the diving dress, the tenders assisting in drawing it up. The diver helps by worming his arms into the sleeves as the tenders work the dress over his shoulders. The diver assumes this bent-over position so that the tenders can conveniently lace up his leg flaps. These are drawn up snugly, but not so tightly as to restrict circulation. Tenders work as swiftly as they can, consistent with safety, out of regard for the diver's comfort. On the surface, the diving outfit is not a very comfortable one. Note how the ends of the lacings are tucked in under the leg flaps. This, of course, is to keep them from fouling. Tenders steady the diver as he steps into his shoes. They draw the lacings up firmly and tie them off with a square knot. Straps go over the ends of the lacing, again to avoid fouling. Buckles must be outboard. If they were inboard, they might snag on each other and trip the diver. Next, the helmet cushion, the horse collar as divers call it. This is an optional item. Some divers use it, some don't. All divers, however, should learn its use. It's a pad to protect the diver's shoulders and simply slips over his head. One tender works the horse collar under the bib of the dress, while the second tender gets the breastplate. Now, the breastplate goes over the diver's head, carefully. There's not too much clearance. Eyelets and halyards, of course, are at the front. A tender tucks the halyard ends up inside the breastplate to get them out of the way. The next step is the all-important watertight seal between the dress and the breastplate. Working one on each side of the diver, the tenders maneuver the rubber collar over the breastplate studs, starting at the back and working toward the front. Alternating from side to side, they manipulate the stiff collar by pulling on the bib. The fit of the collar to the breastplate must be smooth, without bulges or wrinkles. A copper washer goes over the bottom front and bottom rear studs and over the top right and top left studs. These distribute the pressure under the joints between the breastplate straps to prevent gouging and chafing of the rubber collar. Next, the breastplate straps. These are custom fitted in the manufacturing process. Each of the 4 straps must be placed in its own particular position. Getting them in the right place is easy. The front straps are clearly marked. The tenders now install the 12 wing nuts on the breastplate studs, being sure the flanged wing nuts are over the strap joints, and hand tighten each one. The tenders, one working at the back and one at the front, use the wing nut wrench for the final tightening. Notice the grasp the front tender has on the top opening of the breastplate. This is to protect the diver's chin, as the torque of tightening the wing nuts causes the breastplate to tilt and twist. To equalize pressure, each tender tightens from bottom to top, omitting the wing nuts over the strap joints. These 4 wing nuts are tightened in this order: bottom front, bottom rear, and the 2 top ones at the same time. As a double check, in the interest of safety, one tender now tries each of the 12 wing nuts with his wrench to be sure that none has been skipped. Now he removes the wing nut on the longer stud at the left front of the breastplate, where the eye-pad of the air control valve will be secured. The installation and tightening of this wing nut cannot be omitted. Repeat, cannot be omitted. It must be installed and tightened in the proper sequence in order to make a tight waterproof seal between the dress and the breastplate. To protect this exposed stud, the diver covers it with his left hand. It takes both tenders to carry the 84-pound belt. Each holds an end and a shoulder strap, being careful to grasp the strap close to the belt. If they were to take a higher grasp on the shoulder strap, the heavy belt would tend to swing like a pendulum and might knock the wind out of the diver. The tenders place the belt around the diver's waist with the buckles at the rear. They lead the shoulder strap so that they cross at the bottom of the front lower stud, pass outside the top stud at each side, and cross again at the bottom of the rear lower stud. This keeps the belt from shifting while the diver works. Each tender now secures one of the shoulder straps, passing it through the appropriate buckle attached to the belt weights in the rear. One tender fastens both the belt buckles. The diver stands, and the other tender passes the jock strap between his legs. Pulls it comfortably tight as the diver bends and straightens to check the fit. Fastens the buckle and tucks the loose end of the tongue out of the way. Each tender buckles on one of the wrist straps firmly, but not so tight as to restrict circulation. The inflated suit tends to elongate. The wrist straps keep the diver's hand seated in the glove. The helmet is the final item to be fitted in dressing the diver. The air hose and lifeline are already attached. To keep these out of the way, the tender leads the air hose over the top of the left port and the lifeline over the right. He lifts the helmet by grasping the side ports. The helmet is hard and heavy, so the tender places it over the diver's head gently. He positions it so that the faceplate faces a little to the diver's left. When turned into place, the faceplate of the helmet should face directly forward, and the marks scribed on the helmet and the breastplate should be aligned, or nearly so. The faceplate is open now, so the diver can breathe and talk until he is ready to go over the side. The dumbbell is dropped into place, the safety latch closed and secured with a cotter pin. The air hose is passed under the diver's left arm, and a tender slips the iPad of the air control valve over the long stud of the breastplate. He reinstalls the wing nut now, using the wrench to tighten it firmly. Now the tender lashes down the air hose, taking 2 round turns with the halyard and tying off the ends with a square knot. In doing this, the tender takes care to ensure that the air control valve hangs conveniently to the diver's left hand for easy adjustment. The diver's lifeline, which also carries his communication cable, is passed under his right arm, and a tender lashes it tightly with a halyard on that side. He again takes 2 round turns with a halyard and ties it off with a square knot. And now, a last-minute check on the diver's intercom.
Topside, Red Diver. How do you hear me?
Red Diver, topside. Hear you loud and clear. How me?
I hear you the same.
The diver closes his exhaust valve all the way, then opens it by giving the hand wheel 2 1/2 turns. He'll adjust the air control valve as soon as he's submerged on the diving ladder. The final step in dressing the diver comes when the diver feels that all is ready and gives this signal.
Button her up.
The tender closes the faceplate, winds the wing nut down finger tight, and uses the wing nut wrench to secure it tightly. The dressing of the diver is complete, and the diver is ready to go to work. 2 men tend the air hose and lifeline immediately in front of the diver to steady and support him as he moves cumbersomely in the heavy working uniform of the deep-sea diver. In his working environment under the sea, the diver is always conscious of the importance of his equipment. His gear is well designed and well made. The assembly of the gear around the man, or dressing the diver, is equally important to the diver's efficiency, to the accomplishment of the Navy's business, and to the safety and welfare of the man who wears the gear. Deep-sea diving is an exacting trade. The diver may be several hundred feet below the surface, surrounded by tremendous water pressure. He is able to survive and do useful work under these conditions because within his diving dress, he is surrounded by a layer of air. The diving dress that contains this life-giving layer of air is called the standard deep-sea diving outfit. Complete familiarity with his diving dress is the beginning of the diver's knowledge of his trade. In this film, we will examine the construction and function of the standard deep-sea diving outfit. For ease of understanding, we will break the diving outfit down into these groups. First, the various parts that are joined together to form a watertight enclosure. Second, the valves by which the diver regulates his air supply. Third, the weights that overcome the buoyancy of the inflated dress. And finally, a group of accessory items. The watertight enclosure is a continuous shell of metal and fabric. It completely surrounds the working diver, keeping water out and holding air in. It consists of the helmet, the breastplate, and the dress. Let's take them up one by one. The diving dress is a watertight coverall. It's something like a man-shaped bag in that it has only one opening at the top. It's watertight because it's made of sheets of rubber, vulcanized together, and covered, as you can see in this sample, on each side by cotton twill. If punctured or torn, it can be easily patched. There are several features about the dress you'll need to understand. First, the flaps on the back of each leg. After the diver slides into the dress, the flaps are laced firmly. The purpose is to keep air out of the legs so that the diver can maintain the proper buoyancy and balance. The diver wants to keep his feet on the bottom, not discover they're floating above his head. An upside-down position could cause drowning if only a small amount of water leaked into the suit. Around the neck of the dress, you'll notice a kind of loose collar. This is the bib. It's cemented inside the neck of the dress and surrounds the diver's neck very loosely. It's a kind of cofferdam that traps any minor water seepage that might get in around the helmet or breastplate. Around the neck, on the outside of the dress, is the collar of the dress. It's made of heavy rubber, and molded into it are 12 reinforced holes. These holes receive the studs, which are part of the metal breastplate. The breastplate is made of spun copper. It covers the diver's shoulders, chest, and back, and provides a solid foundation for making one watertight seal between the diving dress and the breastplate, and another between the breastplate and helmet. The collar of the dress is clamped firmly to the breastplate to make the first watertight seal. This is the clamping device. 4 breastplate straps, tightened down by wing nuts. But first, to distribute the pressure at the joints, these copper shims are placed over the appropriate studs. Here, 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 and at the bottom rear. The metal straps are custom fitted to each breastplate. They cannot be interchanged. Front ones are clearly marked to make sure that all the straps are correctly placed. The seal between the breastplate and the helmet is a simpler matter. Recessed into the neck portion of the breastplate is a leather gasket. The helmet is forced down on this gasket as it is twisted into place. These interrupted screw threads receive matching screw threads machined onto the bottom of the helmet. As the helmet is turned, the threads force it down tightly on the gasket. To ensure that the helmet cannot be accidentally loosened by colliding with or catching on some underwater obstruction, the breastplate is fitted with a safety latch, a pivoted metal bar, recessed to receive a dumbbell when attached to the helmet. The last feature of the breastplate is this pair of metal eyelets at the front. This is another safety feature. The halyards attached to the eyelets are used to lash down the diver's air hose and lifeline. This takes the strain off the connections, and even though one should part, the other would be available to pull the diver to the surface. Now, let's take a look at the standard diving helmet. Basically, it's a seamless spun copper shell into which a number of fittings have been inserted. The 4 viewing ports are inserts of heavy glass, which give the diver good visibility to the front, to each side, and upwards. Each port is protected by a metal grate, and all are fixed in place, excepting the forward port. This opens so that the diver can breathe and talk while he's being dressed or undressed. This rubber gasket makes it watertight when it's closed. It is secured by this heavy wing nut. The 4 viewing ports make it possible for the diver to look around without turning his entire body. Here at the base of the helmet are the interrupted screw threads that mesh with those on the breastplate. These are partial threads. The helmet is rotated into place with less than a quarter turn. It is rotated so that it is firmly seated, and the front part is facing directly forward. To ensure that it stays in place, the helmet is secured with this safety device called the dumbbell. The dumbbell drops into the recess of the safety latch. The latch is closed and the cotter pin dropped into position. Between the diver working on the bottom and the crew working on the surface are two channels. One is the air hose, through which air is pumped from topside to the diver's helmet. The other is the lifeline, which also contains the communications cable. Both are attached to the back of the helmet. The air hose at the diver's right, and the lifeline at his left. The goosenecks, as they're called, are set at an angle to lead the lifeline under the diver's right arm and the air hose under his left. This keeps lines and fittings from interfering with each other and provides maximum convenience and safety. The helmet, the breastplate, and the diving dress, when joined together, form a watertight enclosure around the diver, keeping water out and air within. Now let's take a look at the diver's air supply. The standard deep-sea diving outfit is what we call a surface-supplied apparatus. Air taken from the atmosphere is compressed, piped to the diver, and exhausted into the water where it bubbles its way back to the atmosphere. In making this circuit, the air passes through 4 valves. Number 1, the air control valve. The diver turns the hand wheel of this valve to control the amount of air admitted to his helmet. Number 2, the safety air non-return valve. The adjusted air supply passes through a short hose and through this valve into the helmet. This is a safety device which requires no adjustment by the diver. The non-return valve is simply a one-way valve. Air can go into the helmet, but cannot go back through the valve. If the diver loses his air supply, the valve closes, trapping a 5 to 7 minute air supply within the diving outfit. This is ample time to replace the air supply or haul the diver to the surface. The 3rd and 4th valves are concerned with exhausting air from the diving outfit. Both are built into the helmet. The 3rd valve, called the air regulating escape valve, is an exhaust valve of double purpose. It automatically maintains an air pressure in the diving outfit slightly higher than the pressure of the surrounding water. And by hand regulation, the diver adjusts the volume of the air exhausted from the helmet, balancing exhaust with intake to control buoyancy. The 4th and last valve is the spit top. This is a supplementary exhaust valve used mainly to make fine adjustments in the diver's buoyancy, and is just a simple on or off device. These 4 valves are so important to the diver's efficiency and safety that he must know how and why they operate as they do. Let's take them up again in the same order, but this time we'll take an inside look. First, the air control valve. There's nothing complicated about the air control valve. It's a simple needle valve having a plunger or valve stem that, when in the closed position, seals against the valve body to completely cut off the flow of air. As the hand wheel is turned, the stem unseats and allows air to pass through the valve and onto the diving helmet. Notice that in either the closed or fully open position, a minimum of 2 threads is engaged. This safety factor means that the valve cannot be over-operated to the point where the valve stem might become disengaged and inoperative. Normally, of course, the valve is in a partially open position, the exact setting depending on depth, desired buoyancy, and exhaust valve setting. The air control valve is secured to the diving outfit by means of a link and an iPad. The iPad slips over the long stud at the left side of the breastplate underneath the wing nut. Air leaving the air control valve passes through a 3-foot length of hose to the helmet. At the helmet, we find the safety air non-return valve. This is a safety device and is not adjustable. It allows air to go this way into the helmet, but not this way from the helmet back into the air hose. If there were no safety valve and the diver's air hose were to burst or his air pressure were to drop because of equipment failure, the air contained in the diving outfit would rush out through the hose. This would result in an imbalance of pressures. High pressure from the weight of the water surrounding the diver and low pressure within the diving outfit. In this case, the greater external pressure tries to force the flexible diving dress and the diver up into the rigid diving helmet. In diving circles, this is known as a squeeze. It can be fatal. Now we take up two other valves whose function is to release air. The major one, the air-regulating escape valve, commonly called the exhaust valve. This is the hand wheel for adjusting the volume of air to be released. Here at the side of the helmet is the port through which exhaust air escapes into the water. This location keeps air bubbles away from the viewing ports. The exhaust valve has a second control, located inside the helmet and operated by the diver's chin. It's called the chin button. The diver depresses it with his chin, or in some cases, pulls it with his lips to temporarily override the valve setting. This cutaway model of the exhaust valve shows how it operates in two ways. First, as a safety device, it automatically maintains an air pressure inside the helmet slightly higher than the outside water pressure. Second, it permits the diver, by hand regulation, to adjust the inflation of his dress, and thus his buoyancy. The heart of the exhaust valve is the valve disc, which opens to allow air to escape, and a pair of springs that control the degree of valve opening. Hand adjustment is made by turning the hand wheel. This regulates the distance that the valve stem travels before it engages the secondary spring. This primary spring is the automatic safety feature. It compresses to release air only when the air pressure is a half-pound higher than outside water pressure. The secondary spring is the stiffer of the two and comes into play only after the primary spring has compressed to allow the valve disc to open. This means that the exhaust valve will not open until there is sufficient air pressure in the diving dress to overcome the outside water pressure. When, and only when, there is sufficient pressure in the diving dress, can the diver regulate inflation and buoyancy by turning the hand wheel. The chin button permits the diver to use his degree of buoyancy as a tool. By depressing the chin button, he overrides the valve setting to dump air quickly. This, in effect, makes him heavier, permitting him, for example, to get more pull on a line. By pulling on the chin button with his lips, he overrides air pressure and prevents air from passing through the exhaust valve. This inflates the dress and makes him more buoyant. He can use extra buoyancy to lift heavy objects or to pass over a large obstruction. There is a direct relationship between the air control valve and the exhaust valve. If the diver is to have the right inflation and buoyancy, along with plenty of pure air for breathing, he must balance the openings of the two valves. The general rule is, open the exhaust valve 2 1/2 turns. Then, adjust air supply for slight negative buoyancy. Men who are exceptionally light or exceptionally heavy will have to modify the rule by experience. The final valve, also controlled by the diver, is another exhaust valve called the spitcock. This is a simple sleeve-tight valve of no complexity whatever. Turning the handle simply lines up two holes, permitting air to escape from the helmet. As you can see, the opening is small. The main purpose of the spitcock is to make fine adjustments in buoyancy, a supplementary adjustment after the air control valve and the exhaust valve have been regulated. Another use of the spitcock is to allow the diver to take in a mouthful of water to squirt on the viewing ports, should they become fogged. So far, we've talked about the watertight enclosure and the air system that enables the diver to work on the bottom. These, of course, are the major parts of the standard deep-sea diving outfit. The next group of items, however, is quite important in its own way. The diver's weights, his belt, and his shoes. Without these weights, the diver, in his inflated dress, would float around like a cork, and for all practical purposes would be helpless. The diver's belt weighs approximately 84 pounds. It's a series of small weights, each of 7.5 pounds, bolted to a wide leather belt. 2 of the weights in the front and 2 in the rear have strap fittings cast into them. Notice how the strap fittings are set at an angle, so that the shoulder straps cross in the back and the front. This keeps the belt from shifting. In addition to overcoming positive buoyancy, the belt has another purpose, to keep the diving dress from elongating due to inflation, and thus raising the helmet above the diver's head. This jock strap is the belt attachment that accomplishes this purpose. The loop end of the jock strap slides over the tongue end of the belt at the diver's back. It passes between the diver's legs and is drawn up tightly and secured to the buckle at the front. In order to be sure that the diver has a low center of gravity so that he can remain on his feet, his shoes are also heavily weighted. Each of the shoes weighs about 17.5 pounds. The upper is made of canvas or leather, protected at the front by a brass toe clip. Beneath, it is a wooden upper sole and another sole of lead. For security, the shoes are fitted with both lacing and straps. After the shoes are laced, the straps are buckled over the laces. There is no left or right shape to the diver's shoes, but there is a correct way to wear them. Worn this way, the buckles would tend to snag on each other and trip the diver. This is the correct way. Buckles outboard for safety. So much for the diver's weights. Now, a group of accessory items designed for the diver's comfort and convenience. This is diver's underwear, usually made of pure wool or a warm blend. It provides warmth and prevents chafing, and is worn alone without any overgarments. When a diver is working moderately hard, one set is usually sufficient. In extremely cold water, or if the diver is relatively inactive, he will be more comfortable wearing 2 sets of underwear. Diver's socks are also made of wool. The diver always wears the socks to cushion his feet inside the rigid diving shoes. Here's an optional item, not mandatory, that many divers would not want to be without. It's the helmet cushion, usually called the horse collar. It's simply a pad to protect the diver's shoulders from the metal breastplate. The last of the accessory items are small in size, but each is important to the working diver. First, the wrist straps. These are just simple leather straps secured comfortably around the wrists. As we said before, inflation tends to elongate the dress. These straps keep the diver's hands firmly seated in the fabric gloves so that he can grasp a wrench or welding torch to perform his work. One of the things he'll use frequently is the diver's knife. Although it's called a knife, it's really a utility tool. It's a heavy, rigid blade of tough tool steel with one cutting and one sawing edge. It'll cut wood, wire, rope, or sheet metal, and is stiff enough to use as a pry bar. The diver is never without it. He keeps it here at his belt, where it's handy at all times. Those are the items that comprise the standard deep-sea diving outfit. The watertight enclosure, the air supply and exhaust system, the diver's weights, and the various accessory items. Other films will show you how to assemble the outfit, a process called dressing the diver, and the basic principles for using the equipment. The use of the standard deep-sea diving outfit is the beginning of your training as a deep-sea diver. Diving is a trade that demands your complete attention. Be sure that you know intimately every nut and bolt, every gasket and valve of your equipment, and that you are completely familiar with its principles of operation.